Hi there and welcome back. This is the last section in Chapter 8 and it does a little bit more work with work. And we've already done some examples with work, knowing in particular that if we have a force which depends upon displacement, then the work is simply going to be the integral of f of x dx. And there are times when f of x is simply the weight of something, which in most of these examples is changing. So remember the old leaky bucket problem that we did? That was an interesting example of how the weight or the force changes as we move along a straight line. So what we'll do is look at another example and just practice a little bit with the kinds of problems that you might expect to see involving work. Alright, so let's look at this example. Imagine that we have a conical reservoir, conical tank, and it's filled to 8 feet with oil, and oil weighs 57 pounds per cubic foot. And the height of that tank is 10, and the radius is 5. And what we notice then, if we just set this up on the XY axis, is that this line right here, kind of the slant height, is either y equals 2x or x equals 1/2 y. Imagine that we have a little slab right here, and its height is y and its thickness is delta y. And what we want to do is imagine that we're going to pump that slab just to the top. So if this distance is y, then we have to pump it 10 minus y feet. And so the big deal now is, what is the volume of this slab? So notice that the slab is like a cylinder, and so the volume is going to be pi r squared h. And r is x, and h is delta y. And remember, x is 1/2 y, and so what we get is that this is going to be 1/4 pi, or pi over 4, y squared delta y, and that's volume, so this is cubic feet. Okay, so the volume of the slab is pi over 4 y squared times delta y cubic feet. So the weight of the slab is pi over 4 y squared delta y times 57 pounds. And that is a force, and it's the force for y feet high. So therefore the total work is what we get when we integrate f of y dy. So therefore the work will be the integral. We're going to go from 0 to 8, remember it's 8 feet high, of 57 pi over 4 times y squared, and remember we're lifting this, 10 minus y feet dy. And that'll come out to be about 30,561 foot-pounds. So there you go. And that's a pretty interesting problem of how you do these. Okie doke. I suppose right in here I need to put in 10 minus y because that's how far we're moving that. Okie doke. See you next time.